Okay, so let's solve our example number 2. So obtain the node voltages in the circuit. So that's it. If we're talking about nodal analysis, is this just a continuous application of our KCL course, right? And of course, the direction of our current. The first assumption of your direction matters. Okay? So therefore, from that assumption, as you are going with the calculation, okay, you must stick to it. Okay, so let's have our second example. So we have this circuit. We have 1 ampere and 4 ampere independent current sources. So for our first step is to put our ground, which is already given. Take note that the ground is connected into our common nodes. Okay, next is of course select the nodes that are not connected to the ground. So we have node 1 and also we have our node 2. Now, upon selecting our node 1 and node 2, the next thing to do is of course to create our current assumptions. So from here, so I will create my current assumption such as this will be my I10, which is equal to the current entering to my 2 ohms. Next is my I12. Take note that subscript may vary on how you would want to understand your circuit. Okay, so this will be my I12 from V1 or potential at my nodal voltage 1 to the potential at my nodal voltage 2. So that's why I12, and I have my V20. Now for our solution is that we would create our KCL at node 1. What would be my possible equation, or what would be my equation? So my 1 ampere is entering to my node 1, so this will be 1, and my I12 is going out of my node from its direction I1 to 2, and my I10 is going out by node, which is I10 is equal to 0. Now, what is my I12? So from the fact that my I12 is going from V1 to V2, so therefore my I12 is equal to V1 minus V2 all over 6 ohm. And but what is my I10? So my I10 will be equal to V1 minus 0 all over 2 ohm, or it can be written as V1 all over 2. Now from that, I may rewrite my equation as 1 minus V1 minus V2 all over 6 minus V1 all over 2, which is equal to 0. So 1 minus V1 over 6 plus V2 over 6 minus V1 over 2. By combining my like terms, I have I would need my calculator in order to show you how do I compute those. So from this I will have 1, so minus 1 over 6 minus 1 half. So from here I will have negative 2 over 3 V1, in which I combine this like term plus V2 all over 6 is equal to 0. So 1 will be equal to 2/3 V1 plus V2 all over 6. This will be our equation 1. Next, let's have our KCL at node 2. So if you take our KCL at node 2, so KCL at node 2, so I have the current entering my node 2 is I12 less I20 less my 4 ampere is going out my node 2 minus 4 is equal to 0. My I12 is equal to V1 minus V2 all over 6. My I20 is V1, okay, V2 I should say. So I20 is equal to V2 all over 7 ohm. So minus V2 over 7 minus 4 equals 0. So by combining like terms, you have V over 6 minus V2 over 6 minus V2 over 7 is equal to 4. So 1 over 6. So using my calculator, I have 1 over 6 plus 1 over 7. I have V1 over 6 minus 13 over 42. V2 is equal to 4. So therefore, this will be our equation. Okay, as I have said, you can mathematically solve for these two unknowns. The equations are unknown, but I prefer to use my calculator in order to show you that you can already use our calculator in solving that one. So you have 2/3, then we have 1 over 6, and we have positive 1, okay, and we have 1 over 6 negative 13 over 42 equals 4. So therefore we have our V1, V2, wait, so let me see my equation. So I have 2/3. If I would transpose my V2, this must be negative, okay, and okay, this must be negative 1 over 6. So negative 1 over 6, we have negative 2 and V2 is equal to negative 14. Okay, this will be our V1 and V2.